Welcome back, everyone, to Foundations of AI. This is a big one, our very first session of Season 3. And we're diving straight into a concept that is absolutely critical for modern AI, uncertainty. Let's get right into it.
So, here's our game plan for today. We're going to break this down into 5 parts. First up, we'll tackle why the real world is just inherently uncertain. Then, we'll uncover the secret sauce of modern AI. After that, we'll dig into why putting a number on all this uncertainty is such a game changer. And finally, we'll get hands-on with 2 ways to do just that: odds and probability.
All right, let's kick things off. In our past sessions, we've mostly looked at AI in these, neat, tidy little boxes, closed systems with perfect rules. But for AI to be genuinely useful, it has to step out into the real world. And the real world, well, that's a whole different ballgame. Just think about a game of chess for a second, right? Every piece is visible, the rules are set in stone, and you can predict the outcome of any move. It's a world of perfect information. Now contrast that with the real world. It's messy, it's unpredictable, and it's full of gaps in what we know. That's the arena modern AI has to play in. And there's no better example of this than a self-driving car. I mean, it's the perfect case study. You've got an AI agent making life or death decisions in a world that is anything but perfect. So what kind of real-world challenges are we actually talking about here? Well, for starters, a car's sensors are never going to be flawless. There's always going to be some level of noise. You might have one sensor saying the road curves left, while another one says it goes right. And then you have the truly random stuff, right? A sudden rainstorm, a piece of trash hitting a camera, or a kid's ball suddenly bouncing into the street. The AI can't just freeze every time there's a tiny hiccup. It has to make a rational call. Okay. So, if the world is this chaotic, how on earth do we build an AI that can actually handle it? This leads us right to the fundamental key that unlocks the power of modern AI. And here it is. This is the secret. The reason today's AI is light years ahead of the systems from a few decades ago is its ability to handle uncertainty using the mathematical framework of probability. Now, to be fair, probability isn't the only method people have tried. Back in the day, you had approaches like fuzzy logic that tried to deal with imprecise data using degrees of truth. Like a washing machine deciding if clothes are kinda dirty or really dirty. But probability has proven to be the most robust and effective framework by far. And today, it's at the core of pretty much every AI application out there. All right, let's move on and see how these ideas stack on top of each other. When you hear the word probability, your mind probably jumps straight to card games or gambling, right? But its importance goes way, way beyond that. This is really all about making rational decisions when you don't know what's going to happen next. And this slide really drives home just how relevant this abstract math is to our everyday lives. We're constantly using probability, whether we realize it or not. We use it to weigh the risk of speeding, to forecast economic shifts, and, critically, in public health, to balance the benefits of something like a vaccine against its potential risks. It's what allows us to compare uncertain outcomes and make smart, informed choices. So here's the key lesson. If you take away just one thing from this section, make it this. Uncertainty isn't some vague, mysterious feeling. It can be quantified. We can actually put a number on it. And once it has a number, we can start to reason about it logically. This quote really just nails the central idea. By quantifying uncertainty, we're pulling it out of the realm of gut feelings and hunches and bringing it into the world of rational thinking, a place where we can analyze it with evidence and actually debate it. All right, so if we can put a number on uncertainty, how exactly do we do that? Let's start with one of the most intuitive ways to think about it, by expressing it as odds. Odds are really just a simple ratio. When we say the odds of you winning a bet are 3 to 1, it just means we expect you to win 3 times for every 1 time you lose. It's a straight-up comparison of the outcomes you want versus the ones you don't. So, why start with odds? Well, it turns out research shows our brains are just better wired to grasp these natural frequencies. Saying 3 times out of 4 feels a lot more intuitive to most of us than saying 75% or a 0.75, even though they all mean the exact same thing. Okay, now this brings us to a really, really critical distinction. The terms odds and probability get thrown around interchangeably all the time in normal conversation. But in math and AI, they mean very different things. Let's make sure we get this crystal clear. Let's take odds of 1 to 5. What this means is that for every 1 time you win, you lose 5 times. So the key here is to look at the total number of events. That's 1 win plus 5 losses, which gives us 6 total events altogether. And this is where people get tripped up.
Odds of 1 to 5 mean you win, on average, once every 6 total games. But a probability of 20% means you win, on average, once every 5 total games. They are not the same thing. The denominator, the total number of trials, is different.
Luckily, there's a super simple formula to convert between the two. To get the probability from odds of x to y, you just take your desired outcome, x, and divide it by the total number of outcomes, which is just x plus y. So let's circle back to our first example. If the odds of winning are 3 to 1, we just plug that into our formula. The probability is 3 divided by the total, 3 plus 1. That gives us 3 over 4, which is 0.75, or 75%. See? Simple as that. Okay, so now we have the basic tools to put a number on uncertainty. But here's the thing. The world doesn't stand still. New evidence is always popping up. And that leads us to the next big question, which we'll dive into in our next session. How do we logically update our beliefs when we're faced with new information? That's where things get really, really cool. I'll see you then.